Mitakaku, a really influential physicist, opened up about a mind-blowing discovery. He's famous for his work in physics, and he confirmed that the James Webb Space Telescope spotted 6 huge galaxies that scientists thought couldn't even exist. This could totally change how we see the universe, so it's a big deal. Kaku's this cool American-Japanese physicist who knows a ton about both old-school and quantum physics. He's not stuck in his ways like some scientists, and he's totally on board with what the James Webb Telescope found. It's awesome that he's speaking out about something you just can't ignore. You can tell he's excited, maybe even a little amused, by what the telescope found. He said it's really got him thinking. So, let's get into what Mitakaku thinks about these giant galaxies. He's always been open to new ideas, admitting that Einstein's relativity and Newton's laws don't quite cover everything in space. He gets that the telescope's findings could really change the game, even if some other scientists aren't so thrilled. This whole thing is kind of funny to Mitakaku. The telescope found these 6 massive galaxies from way back in the universe's early days. They have way more stars than our Milky Way, even though they formed super early, only 200 to 700 million years after the Big Bang. The astronomers who found them call them universe breakers because if they're real, they flip our understanding of everything. Something's not adding up here. The Big Bang Theory says the early universe was a mess. It took ages for stuff to form, and even longer to get dense enough to shine. Galaxies were supposed to come much later. But these galaxies are huge, even bigger than the Milky Way, and they're pumping out stars like crazy. Researchers still don't know exactly when the first galaxies showed up. All they know for sure is that there were probably just stars or small groups of stars that eventually joined up to make dwarf galaxies. These little guys crashed into each other and got bigger. Past theories said big, organized galaxies couldn't be around so early. So, is the universe way older than we thought, or did galaxies form way faster? Some scientists are having a hard time with this, especially those who are really attached to the Big Bang Theory. It's got some people worried and stressed, but Mitakaku just finds it amusing. He knows that some outdated ideas stick around because some famous scientists push them. He says that experiments are what keep theorists honest. Truth is, we don't know a whole lot about where the universe came from. The Big Bang Theory, which popped up in 1927, came from seeing that the universe is getting bigger. This led to the idea that it started from one point and has been expanding ever since. Back then, it was hard to think about a universe with a beginning and an end. Even now, it's a tricky idea to wrap your head around. These new findings mess with the stuff researchers have based their work on for decades. But science has shown us again and again that we need to rethink things and be open to new ideas. Observations are what make theories real. Back when Einstein was a kid, people thought stars and planets were stuck in place. Now we know everything's moving. Planets go around stars, stars zip around galaxies, and galaxies zoom through space. Where it's all headed? No one knows. Scientists are starting to realize they have to get rid of some old, comfy ideas. Theories are just guesses until they're tested and proven right. The Big Bang Theory came from seeing that galaxies are moving away from each other, and the farther they are, the faster they're moving. This is called Hubble's law. Stuff like cosmic background radiation and the redshift of light from far-off galaxies seem to back it up. But think about it. People used to think the Earth was flat and the sun went around us, and they had evidence for it too. Then new observations and better technology showed them they were wrong. We're in the same kind of situation now. Scientists thought the James Webb Telescope would prove the Big Bang Theory right, but instead it found these 6 weird galaxies. It's a reminder that science is always changing, and you have to be open to new stuff. Researchers use redshift to measure things in space. Redshift is like the Doppler effect, where the color of light changes depending on how the light source is moving compared to you. If a star's moving toward you, the light shifts toward blue. If it's moving away, it shifts toward red. Physicists use these red shift numbers to figure out speed and distance. But even small mistakes can mess things up. The ways they've been measuring things are now being looked at, and it'll be interesting to see what they find. So, are these new discoveries just because of redshift errors, or are some scientists just refusing to face facts? That's what we need to figure out. Thanks for watching. Leave your thoughts in the comments. Like the video, share it, and subscribe for more. See you next time. Space research is showing us that scientists need to be flexible and ready to change. New stuff can shake up old ideas. The James Webb Telescope's discovery of these 6 big galaxies proves that. As we keep studying space, we need to remember that the universe might be way more complicated than we thought. These galaxies, which are way older than they should be, might mean we have to rewrite the rules. This isn't just a weird thing, it's a turning point in science. Scientists like Kaku are saying that we don't know everything, and every new discovery adds another layer to the story. Some people in the science world aren't happy about these new findings, but that's normal. Big changes usually face resistance. As Kaku says, history is full of examples of old theories getting replaced by new ones after big experiments. Being open to change is what moves us forward. These new findings aren't just about messing with old theories, they could also open up new research areas. If we can figure out how these big galaxies formed so early, we might have to rethink how galaxies form in general. We might even need to change our models of how the universe evolved. As we get more data, we could be entering a phase in cosmology that challenges everything we thought we knew. Kaku's take on it is important because he's willing to embrace new stuff, no matter how weird it is. His support for the telescope's discovery shows that science is becoming more open to new info. Scientists have always used data and testing to figure things out. But sometimes the data leads us to unexpected places and makes us rethink everything. Scientists like Kaku remind us that learning is a never-ending thing. We're always looking for new data that could change how we see the universe. Whether it's new telescopes or new ideas, the quest to figure out the cosmos is far from over. These recent findings are probably just the start of something big in astrophysics. As we move forward, we need to remember that science is a process driven by curiosity and a need to find the truth. The James Webb Space Telescope's discoveries aren't just the work of a few people, they're part of a team effort to unlock the universe's secrets. Every new piece of data adds to the puzzle, and every discovery gives us a new way to see things. It's an exciting time, and it encourages us to stay interested in the wonders of space. The questions that Kaku and others are asking remind us that there's so much more to learn. Maybe as we find new stuff, we'll see even bigger changes in our understanding of space and reality. This is just starting, and who knows where these might take us. Thanks for following along as we explore these new discoveries. Keep asking questions, keep searching for answers, and keep exploring. Our understanding of the universe is still growing, and with every discovery, we get closer to understanding how things work. These findings are a big deal, not just for what we know about the universe, but also for the big questions that scientists have been asking for centuries. Humans have always wondered where the universe came from. The Big Bang Theory has been a main way of explaining it, but these new discoveries challenge that. The galaxies found by the James Webb Space Telescope suggest that the universe could be way more complicated and older than we thought. This makes us rethink everything from how galaxies form to how the cosmos is structured. As Kaku and others have said, it's important to be open-minded about these new findings. Science is about questioning, testing, and improving ideas. What we thought was true might not be true anymore as we find new evidence. The doubt surrounding these discoveries is normal in science, and it's important for pushing the boundaries of knowledge. But those who are ready to explore these weird things are super excited. It's worth pointing out that finding galaxies that formed so early in the universe is a big challenge to current models of space. As we deal with these big discoveries, the impact goes beyond just galaxy formation. The discovery of these 6 massive galaxies, which are way older than we thought, could change how we see the universe. If these galaxies really existed so soon after the Big Bang, it means the early universe was way more active than we thought. This questions the idea that galaxies took millions of years to form after the Big Bang. It suggests that galaxy formation might have been much faster than scientists thought. Such discoveries could make us rethink not only how galaxies form, but also how the cosmos evolved. Could these older galaxies represent a burst of star formation that set the stage for the rest of the universe? These questions could make researchers reevaluate models of dark matter, dark energy, and how cosmic inflation shaped the universe. Besides changing our understanding of space, these findings also show how amazing the James Webb Space Telescope is. It's allowed us to see further back in time than ever before, giving us views of the distant past. With more discoveries likely to come, the telescope will keep opening new doors for learning and answering some of the universe's deepest questions. This new phase will likely lead to more teamwork between scientists who now have to come together to challenge old ideas, design new models, and test theories. Being willing to question long-held beliefs, as Michioku says, is a key part of science, and we're likely seeing a turning point in the story of cosmic discovery. As our tools get better, our understanding of the universe will keep growing, creating possibilities for future breakthroughs.